Sometimes you see something in nature that just completely defies logic. Well, get ready because today we're diving into one of the most mind-bending feats of engineering out there. Living bridges built by ants. Seriously, it's a phenomenon that'll make you completely rethink what intelligence even means.
Okay, so picture an army ant. On its own, it's tiny, right? But when you get thousands of them acting as one, they literally become a superorganism. So when they need to cross a gap in the forest floor or get to a new food source, they don't bother looking for a fallen leaf to walk over. No, they become the bridge, linking their own bodies together in this just incredible display of cooperation.
And here's the real mystery, the thing that just blows my mind. There's no architect ant, there's no foreman ant shouting orders, no one has a blueprint, the queen isn't sitting in some command center directing traffic. So how? How does this complex, totally functional structure just appear out of nowhere? Well, the answer is this amazing concept that, believe it or not, is actually changing our world.
It all boils down to something called swarm intelligence. Now, what is that? It's basically the idea that a whole group can be way smarter than any single individual in it. It's not that each ant is a genius, far from it. It's all about each one following a few very simple rules based on what's happening right around them.
So, and this is the crucial part, you really got to get this. Not a single ant in that bridge has a clue it's building a bridge. Not one. It's a completely bottom-up process. Each ant is just doing its own thing, reacting to what's immediately in front of it. The touch of another ant, a chemical trail, that's literally it.
And that, right there, is a perfect example of self-organization. You get this incredibly complex order just emerging from super simple local interactions. The brain of the operation isn't in any one ant. The intelligence is a property of the entire system working together. So, okay, let's break down how this actually happens.
So, how does it all start? Okay, so one ant gets to a gap. It stops, but the ants behind it, they don't stop. They just start crawling right over that first ant, linking their legs to its body. Then more ants crawl over them, and suddenly, you've got a chain. As more and more ants start walking across, their weight pulls the whole thing tight, and that pulls even more ants into the structure, making it thicker and stronger until, bam, you've got a stable, living highway. But here's what's really wild. The construction never actually stops. This isn't like building a bridge out of steel and then walking away. It's a living, breathing thing. The colony is constantly, and without even knowing it, running this complex calculation to make sure the bridge is as absolutely efficient as it can be. I mean, think about it like this, right? Every single ant that becomes part of that bridge is one less ant that can go out and find food or defend the colony. That's the cost. The benefit, of course, is a super efficient highway to get to the resources. The swarm is always balancing this trade-off, constantly tweaking the bridge's size to find that perfect sweet spot between cost and benefit. What you end up with is just a masterpiece of adaptive engineering. This thing can move. It can stretch if the gap gets wider. It can thicken up to handle rush hour traffic. And the best part? When the food runs out or a better path opens up, the bridge just dissolves. The ants just unlock from each other and walk away, like it never even happened.
So this is way more than just a cool, fascinating fact about nature. This whole idea of collective problem solving is so powerful that we humans have actually started borrowing the logic to solve some of our own biggest, most complex challenges.
Yeah, it's led to a whole field of computer science called ant colony optimization, or ACO. We're talking about algorithms that are literally modeled on how ants use those chemical pheromone trails to find the shortest path to food. We've basically taught our computers how to think like an ant colony, and it's helping them find the best solutions to some ridiculously complex problems.
And you see the results of this ant logic everywhere, maybe without even realizing it. It's used to route your internet data through telecommunication networks. It's used to create those massive realistic crowd scenes in movies. It even helps airlines figure out the best way to assign planes to gates to cut down on delays. We are literally using swarm intelligence to make our own world run better.
And all of this kind of leads to this really fascinating shift in how you see things. Maybe the best way to think about it is to stop seeing an ant as an individual at all. In the context of the swarm, the colony is the organism. And each ant, it's just a single cell, doing its one simple job to contribute to the life of the whole.
So that leaves us with a really powerful question to think about, doesn't it?
When you look at huge problems like managing city traffic or coordinating disaster relief, what could we solve? What other massive challenges could we tackle if we started thinking less like individuals and more with the decentralized, super adaptive power of a swarm?